So in this video we want to look at solving some more advanced types of trig equations, as well as to solving over the set of real numbers. So in our first example we have cosecant squared x. Now just on the note of what that means, whenever this notation is used, that means that it's the entire trig ratio squared. So these are equivalent. Alright, so what I really got here is an equation in which something is being squared. It's kind of like having x squared minus 1 equals 0. And if you were to solve that equation, you could solve or isolate the square and then square root that to get plus or minus 1. Okay, so we're going to do a similar kind of thing here. We're going to isolate our square. Cosecant squared x is 1. Square root both sides. Okay, so you want to get your trig ratio isolated. And now we need to turn this over to one of the primary ratios, sine, cos, or tan. We know that the reciprocal of cosecant is sine. So this is the sine of x equals the reciprocal of plus or minus 1, which is actually the same thing, plus or minus 1. Sine being plus or minus 1, we can actually figure that out from the unit circle, because we know that sine is the y-coordinate on the unit circle. So the question is, do we know on a unit circle where the y-coordinate is plus or minus 1? Well, that would have to be at an angle of 90 degrees, although we want to work in radians, but we'll talk about that in a second, because this point here would be 0, 1. Remember, sine is the y-coordinate on the unit circle. Or the angle is here, from standard position, 0, -1. And those are all the angles between 0 and 2 pi that have a sine value of plus or minus 1. So therefore, our particular solution, our solution on this interval, would be that x is 90, which is pi over 2, or 270, which is 3 pi over 2 radians. Now the second part of this question is to give the solution in a different way, and what we want here is the solution over the set of real numbers. What that means is that if you were to continue to take each angle and go now around another revolution, so we're talking about all the other angles that are coterminal to these two, to list all of those. So we have pi over 2 as one solution, but then we have pi over 2 plus 2 pi. And then we have pi over 2 plus 2 times 2 pi, etc. And before that we have pi over 2 minus 2 pi, etc., etc., etc. And similarly with 3 pi over 2. So the way that would be all the angles, because they would go on endlessly in either direction in that pattern, that we need to list in terms of giving a solution for all real numbers. So x could be pi over 2, and the way we can generalize this is we can say plus 2 pi once, twice, 3 times, n times, where n is an integer. And I use integer because I can be subtracting as well. Subtracting 2 pi, subtracting 4 pi, etc., etc. And same thing with 3 pi over 2. So here is another advanced type of trig equation that we want to solve. This time we have a term with a square and a non-square. And so just to simplify this a little bit, if we were to think of the cosine x as just like y, then this equation would be like y squared minus y equals 2, which would then maybe be more obvious as a quadratic equation, which we know to solve we would set to 0, and would use the quadratic formula or factor it. And this one's factorable. And then we could solve. Now we're going to do the exact same thing, except thinking of the y as cosine x. So we can set our equation to 0 because it's quadratic like. We can factor it cosine x times cosine x at the front. Two numbers multiply to -2 and add to -1. And then solve these two, we get cosine x is 2, or cosine x is -1. Okay, so what we've really done to solve this is we've taken our complicated equation and brought it down to two simple trig equations to solve. The solution to this starting equation will be the solution of these two individual equations. So where is the cosine of x 2? Okay, a couple of ways you can make a decision on that. First of all, we are in radian mode because 0 to 2 pi. So be sure you're in radian mode, which we are. And inverse, because we're finding an angle of 2. And it says error. So something's wrong, either with the way we entered it or the concept. And the problem is that cosine, we know, is the x coordinate on the unit circle. Well, on a unit circle, the radius is 1, so there's no way you can have a cosine or sine value more than 1. So that makes sense that there is no answer to this. So, no solution to this section. Over here, is there an x coordinate on the unit circle of -1? Now, just as I say that, just be careful here. We also, in this question, have an x, which is the angle, okay? The x on the unit circle is a different x than this x, right? The x is the angle. Okay, so on the unit circle, an x coordinate of -1 occurs at this point. That means that my angle, which is the x in this question, is 180 degrees, which is pi radians. And that's my answer. That is my particular solution on this interval. Now to find my general solution, my solution over the set of real numbers, in other words, I need to take my answer of pi and find the coterminal angles that go with that. Well, I could simply say x is pi plus coterminal is 2 pi, add or subtract it on n times. Okay. Or another way to say it, okay, there's often more than one way to state a general solution. If I thought of this as being pi, add 2 pi is 3 pi, add 2 pi is 5 pi, and backwards would be minus pi, etc. What I could say is that the general solution is n pi, where n is odd. So 1 pi, 3 pi, 5 pi, 7 pi, right? Or even another way to say it would be, since odd integers are of the form 2n plus 1, if you put any integer into this, it's going to produce odd numbers, 1, 3, 5, 7. So you actually have three different ways that you could state the general solution. 1, 2, and 3.